Hello, my name is Oscar, and this is my Quiet Learning Environment Monitor. The goal of my system is to encourage quieter studying spaces, aligning with the United Nations SDG number 4, quality education. My system senses ambient noise, analyzes it in MATLAB, and responds through an LED light sensor, as well as a noise monitor graph. Now, in just a brief overview of my system, this is what it looks like. So I have this cable, which is connected to port A2. This is my sound cable. I'm using this cable to detect the light. This is A number 4. And then my final one is D4, and this is for my LED sensors. This right here is my main code, the Quiet Monitor M. Essentially, this code initializes the hardware, collects the calibration samples, computes a baseline mean and standard deviation. It filters the data using moving average, which I have right here, as well as converting the sound reading into a normalized score between 0 and 1, and it updates the system state. You can see MATLAB communicating with the board. Every reading is captured and timestamped. Now this is the Quiet Monitor main running. Essentially what's happening here is if I speak into it, there will be a minor spike. These are my mean and STD values. There will be a minor spike followed by a usual fall as I'm speaking into the sound sensor right now. It should naturally drop down. And then if I speak into it again, there will be a minor spike. Now that we've analyzed and proven how my noise monitor graph and sound sensor works, we're going to look at the three main functions: compute noise score, moving average filter, and update state. The compute noise score function converts raw voltage to a noise score using baseline calibrations. Just to show it off. My moving average filter smoothens the single signal to avoid false triggers. And the update state handles the state machine and the hysteresis process, which prevents rapid switching between states. Overall, I feel that this project really helps me apply almost every single course learning outcome. I practice problem solving, debugging, and unit testing, which also address the CEAB indicator on programming and data visualization. I use procedural programming constructs like loops, conditionals, and modular functions. I even worked in a real IDE interface with physical hardware. I collected sensor data and plotted it in real time. I modeled environment noise mathematically and implemented a decision-making algorithm based on thresholds. I also considered safety and responsible hardware use during testing, which really made my experience with the Grove board during this project much better. And I feel that this project demonstrated my ability to connect sensing, reasoning, and actuation into a complete system.